Welcome. This session will continue the discussion on analytic functions. And more specifically, we are going to discuss about conjugate function. So functions are said to be conjugate if the functions u and v are sometimes called conjugate functions. So given 1, we can find the other within a given additional condition so that u of xy plus I v of xy is analytic. So example, find the analytic function w equals to f of z given by u of xy plus I v of xy from its real part and when z is 0, the function is 2. So that's what we have. Solution for this. We have u given by 2 e raised power x cos of y. This is given. Now, partial u partial x is 2 e raised power x plus y, and partial u partial y is negative 2 e raised power x sine of y. Now, we know that from Cauchy-Riemann's equations, partial u partial x the same as partial v partial y. So this will give us 2 e raised power x cosine of y. Let me call this one equation 1. And partial u partial y is minus partial v partial x. So which means partial v partial x is equals to, when you negate this, you get 2 e raised power x sine of y. Call this one equation 2. Now, by total differentiation, this was done in differential calculus. We know that total differential of v is the same as partial v partial x dx plus partial v partial y dy. This is just by definition of total derivative. So we'll say dv is equals to now partial v partial x from our solution is given by 2 e raised power x sine of y dx plus partial v partial y is 2 e raised power x cos y then dy. So next, call this one equation 3. Next, integrate equation 3. That is integral of dv equals to integral of 2 e raised power x sine of y dx plus integral of 2 e raised power x cos of y dy. Now, because for this first thing, so this will give us v. This will give us now, we are doing integration with respect to x, so I can factor out 2 sine y. This other one is with respect to y, so I can factor out 2 e raised power x. So then, this means that v, this one will give me 2 e raised power x sine of y. Now, because this is e raised power x plus integration of cos is sine, so this is 2 e raised power x sine of y, and then plus, say, c, constant of integration. But now, when you're doing this kind of problems, care should be taken at this stage. You see, these two integrals are resulting into the same value. This and these are the same. So usually we ignore one of these common things and then just pick one. So therefore, v of x, y is 2 e raised power x sine of y, then plus c. So which means f of z given by u plus iv is the same as u is 2 e raised power x cos of y plus b, which is 2 e raised power x sine of y plus this c I. Now, when z is 0, we were told that the answer should be 2. So it means that if we replace 2 for f of z and put, so remember z equals to 0 implies x equals to 0 and y equals to 0. So 2 will be equals to 2 e raised power 0 cos of 0 plus 2 e raised power 0 sine 0 plus c times I. So this will be 2 equals to 2 plus ci. So ci equals to 2 minus 2 is 0. So which means c is 0 over I, which is 0. So therefore, f of z is the same as 2 e raised power x cos of y plus 2 e raised power x sine of y I. But we can simplify this one further and say this is 2 e raised power x into cos y plus I sine y. But this is a definition of e raised power yi. So which can be written as 2 e raised power x plus yi, which is just 2 e raised power z. So therefore, the required function f of z is nothing but 2 e raised power z. So that is how we solve that question. Next question. Find the conjugate function v, given that u is 2x into 1 minus y. This is number 2. Now this, we say u is 2x minus 2xy. This is what is given in the question. Partial u partial x equals to 2 minus 2y partial u partial y equals to minus 2x. And by Cauchy-Reymann's equations, partial u partial x should be the same as partial v partial y. So which means partial v partial y should be taken to be 2 minus 2y. And then partial u partial y is the same as negative partial v partial x, which means partial v partial x is a negative of partial u partial y. So when you negate this, you get 2x. So we can call this equation 1, can call this equation 2. Now, the total differential, this from differential calculus, is dv is partial v partial x dx plus partial v partial y dy. So this implies, if I call this one 3, replacing 1 and 2 in 3, we have dv equals to partial v partial x is 2x dx plus partial v partial y is 2 minus 2y dy. Call for integrating both sides of 4, we have integral of dv, integral of 2x dx, integral of 2 minus 2y dy. Now this will give us v. This will give us x squared. This will give us 2y. And then this will give us minus y squared, then plus constant of integration. Now, like in the previous case where after the integration process, there are two exactly the same terms. Here we don't have any terms which are exact. So the v remains the way we have it here. So therefore, this is the conjugate function with the given u. So that is how we usually find conjugate function. Maybe just lastly, given number 3, u is x squared minus y squared minus 2xy minus 2x plus 3y. Find its conjugate function v. Now, solution for this. First, partial u partial x is 2x, and then minus 2y minus 2, and partial u partial y is minus 2y minus 2x plus 3. So by Cauchy-Riemann's equations, partial u partial x should be partial v partial y. So which means partial v partial y is 2x minus 2y minus 2. And partial u partial y is negative partial v partial x, which means call this one equation 1. Partial v partial x is the negative of partial u partial y. So when we get this, we get positive 2y, positive 2x, and then negative 3. Call this one equation 2. Then by total differential, we have dv is partial v partial x dx plus partial v partial y dy. Call this one 3. So what we do, we replace 1 and 2 in equation 3, integrate and get b. So replacing 1 and 2 in 3, we get dv equals partial v partial x is 2y plus 2x minus 3, then dx plus partial v partial y is 2x minus 2y minus 2. and then dy. Call this one equation 4. Now integrating equation 4, we get integral of dv integral of 2y plus 2x minus 3 dx plus integral of 2x minus 2y minus 2 dy. So integration of dv gives this with respect to x will get 2yx. This will give us plus x squared. This will give us minus 3x. With respect to y, we get 2yx. With respect to y, we get minus y squared. Now this would be minus 2y, then plus constant of integration. Now, in this kind of problems, once you have done the integration part, check the result you have and any repeating terms, ignore one of the repeating terms. So for instance, 2yx and 2yx are repeating, so we'll ignore this. Those are the only terms that are repeating. So therefore, v will be x squared minus y squared plus 2xy minus 2y minus 3x and then plus c. So that will be the correct v function or the correct conjugate function with respect to the u that was given. These are very critical points. Don't add this and this one and say now we have 4xy. Common terms, ignore one and pick one from the list. Thank you.